Welcome to the first tutorial in week 6. We're going to be covering mouse tracking, a couple of objects that allow us to draw on the screen, as well as the P control object and a few other useful objects in Max. This is the last week we'll be dealing primarily with Max. After the break, we will start looking at the MSP part of Max, so digital signal processing objects. And that will open up a whole new world of possibilities. Okay, so let's get into this one. Week 6.1, please open the patch and follow along. The first object I wanted to look at is the mouse state object. And the mouse state object returns information about the mouse or trackpad. Basically whether the mouse is down, and if it is down, where the location of the mouse is on the page, really in the window, from the very top left corner down to the bottom right corner of the window. So what I've done here is I've got this active object. An active object will send a 1 when the window is active, and sends a 0 when the window is not active or moves into the background. So this is just a way of saying, do we want to track at all the window? Or do we want to, we're actually working in a different window, and so we don't want to track. This message goes into a gate, and this basically controls a gate. So that just simply means that when the window is active, the gate's open, and when the window is not active, the gate is closed. But basically what happens, though, is when the window is active, we bang mouse state, and it will return information about the mouse button. When the mouse button is down, you can see this is a 1. Okay? And when the mouse button is not down, it's a 0. This goes up and through the gate, assuming the gate's open, and then we just do a select. And if the mouse button is down, we poll the mouse state, and if the mouse button is not down, we do not poll the mouse state. And polling really allows us to track the XY location of the mouse. Okay, so maybe I should put a menu or a message box in here, just so you can see. This is the Y location. So when my mouse is down, I'm tracking my Y location. And obviously, I'm tracking the X as well, but I'm not showing it. Okay, so, and the other thing is that I've just set this mode 1 into the mouse state, and all that does is to track just within the window, the coordinate system of the window, not the coordinate system of the entire screen. All right, and so I'm taking I've put a little graphic in here, just drag and drop a graphic in here, and I've put, this is going to be my velocities high and my velocities low, and my pitch is low and my pitch is high. And I'm just going to move my mouse in this area with the mouse button down. And then the X and Y locations, I'm just doing some calculations to give me values that I can turn into musical notes. I could actually use a scale object here. But I've decided just to do calculations. And the other thing I do is I invert the Y values, because the Y values would be low here and high here. And I would like them to be high here and low here. So this exclamation minus is basically 300 minus the incoming value. So it's kind of a reverse subtraction. It doesn't subtract a value from the incoming number. It subtracts the incoming number from the value that's in the object. And the division by 2.2 is just because my numbers would be too high. This covers about more than 200 pixels in either direction. And I want a range between 0 and 127. Okay, so let's just draw in here and we'll see what happens. Okay, and this would be... Okay, so I just created a sort of interactive chromatic piano player where I can use my mouse to generate those values. The rest of this is pretty simple. I'm just, doing a split to make sure that I'm not getting pitches greater than 127. I'm assuming the velocity is going to be fine. I could do the same thing with my velocities. If I change the channel to channel 10, I would get percussion sounds. And I have a speed limit in there. I can't remember if we've looked at speed limit already in this course, but speed limit takes an argument which is the time in milliseconds, and it will not let values through if they are less than 50 milliseconds from the previous value. So it's kind of like a gate that keeps opening every 50 milliseconds to let that data through, and then it immediately closes again. And it's a useful object to control the density. Otherwise, I would probably get too many notes. I've got a lot of notes coming out, but that would be too many notes. I've got a pick slider in here, and rather than doing this, I could have just as easily used a pick slider. You can see I've got the X values and the Y values, X coming out here, Y coming out here, and I could move this around. And I can actually set it up so I can put a picture in here, and I can redefine the appearance of the little control in the middle if I want to create my own graphics there. So I think that's all I wanted to cover with this. I don't think there's anything particularly tricky about that. I should say that since I think about it, since I just thought about it, there's an object we haven't covered, which is the scale object. And I think it's such a useful object that I think I will mention it. And it can deal with integers and floating point numbers. But if you want to scale, let's say I have values between 1 and 127, and I want them to be scaled between 0 and 1. That simply means that incoming values between 0 and 127 will be scaled so that they're between 0 and 1. So I'm going to put an integer in here and a floating point here. And you can see that if I get up close to 127, I got a value of 1. Right? So and it can be reverse scaled so that I could go from 1 to 0. And when I get down to 0, I'll be at 1. And when I get up to 127, I'll be at 0. So a really useful object. I could have done this just as easily. In here, I could have replaced these calculations and simply said, well, what is the range of incoming values I have, and what is the range of outgoing values I want to have? And in some ways, that would have been a cleaner way with one object to scale the X and to scale the Y rather than doing all of these calculations. So I'll mention that, and that's an object that we'll be using in the MSP part of the course quite a bit. All right, way over here, there's a p-control object, and the p-control object goes into a patcher. And the p-control object allows us to send messages that control a patcher. And one of the most common ones is to send the open message into a p-control. A p-control is attached to a patcher. That means the patcher has to have an inlet that it can control to. And by clicking on this, I can open up the patcher. Okay, so that's a nice way of creating an interface. And if you would like, I mean, obviously this could be hidden so that in my patch I might simply have just an open button, or I could even use a graphic and put the open message underneath the graphic. So there are a number of ways that I can do that to make a nice interface, but this would allow me to open a patch without having to double click or assume the user knows how to use Max. And you see up here there's the inlet. I need to have an inlet if I'm going to use p-control because I need to be able to connect to the object. And in here I have an LCD object, which is a graphical object in Max. Just type LCD, all capitals, and it will create a drawing area. You can send messages to draw into an LCD D if you want to draw rectangles or ovals or lines and so on. But you can also put your mouse into an LCD and just draw. And this unpacks the XY coordinates. I have another speed limit so I don't generate too many notes. And then here's another object that's useful, the expression object. And it's a rather complex object, but it allows you to create mathematical expressions which can be quite long and quite complex. And rather than going into all the possibilities, look up the EXPR object and you'll see that you can have absolute values and square roots and multiplications of floats or ints. And this $I1 simply refers to, it's an integer because it's an I, and the $1 is the first value coming in. So if I happen to have an I2 in here or an F2 in here, then I would have another inlet in my expression. So this 128 minus $I1 simply means it would be exactly the same as that exclamation minus space 127 that I had before. Just inverts the values. And so I should be able to draw in here. There we go. And I can clear it and draw another picture. So just a fun little mouse drawing utility. And then I just have a few examples here of speed limits, just so you can see that, if I move this up and down with a speed limit of 250, I'm only getting a few values coming through because most of them are blocked. And if I increase this to something large, I could be moving this up and down, but I hardly get any values. Only once a second does the speed limit open to allow a value through. Here's a metro running at 1,000 with a speed limit of 2,000. You can see that only every other bang actually gets through. And finally on this patch is the preset object. Now we've talked about it before. I just wanted to mention it one more time. It's very useful for allowing the user to choose some predetermined presets. And so if I go in and select these, I can see that these two objects, which are connected to the presets, have different settings every time I choose a different preset. And reminder that to set it, I have whatever objects are connected, I hold down the Shift key and then click on the preset. And then when I go to that preset, it will remember those values that I've selected. Okay, so again, it's probably something you should be including in your patch so that the user can, rather than having to go and set a whole bunch of user interface objects, they can just click one place and you will have created an interesting configuration of all those interface objects for the user to try out. Great. So I wanted to make that a fairly short video. That's week 6.1.